All right, guys. We're back from the interruption with the Zoom. So, as I was saying, we would just look at those number of elements. We count them. So the number of elements in A, which are the odd numbers, would be simply 5. And the number of elements in the universal set would be all the members, including those in A, all the members in the rectangle. And if we count, we get 9. And so in terms of the probability of odd numbers, we would have 5 out of 9. All right. So that's how we represent probability using a Venn diagram, right? And remember, in mathematics, diagrams are important because we say diagrams worth 1,000 words, all right? So here we are looking now at what we call the probability scale. Now, one of the things that we can conclude is that since we are measuring the probability as a fraction of a whole or a fraction of a total, we can safely say that our probability cannot be greater than 1 because it has to be a fraction, right? It cannot be greater than 1 and it cannot be less than 0. So in terms of measuring probability, our scale would range from 0 to 1, and any fraction between 0 and 1 would be legitimate values that we can use to measure probability. But you cannot have a probability like 1.5. If you get a number greater than 1, you know that is not possible, right? Because a probability must be measured based on a total, right? And what you're in favor must be a fraction of that total. Is that clear to you guys? Raise your hand if that is understood. All right, so with that said, the scale refers to the probability of something not happening being 0. So if the thing doesn't have a probability of happening, then we say that the probability is 0. And anything that has a probability of 0, meaning that that thing is impossible to happen, right? Now, remember now, when we're looking at the likelihood of something happening in terms of probability, the smaller the fraction is the less likely it is for something to happen. So if you have 0, that means you wouldn't have that thing happening at all. Now, the greater the fraction, then the more likely it is something going to happen. And the greater the fraction is, the closer you get to 1. And the closer you get to 1 in terms of a probability, or in terms of the fraction when you calculate a probability, it means that it is the greater the chance of that thing happening, or that outcome. If you are in favor of an outcome that has a high probability, it means that it has a high chance of happening. So the likelihood of it happening is great, right? And if you understand about the likelihood of happening, then in that case, you can make a bigger bet because you know you stand a better chance. So the larger your probabilities, the more advantage you have in terms of winning. So people will pay attention to the likelihood of things happening. And if it is likely to happen, they will take a chance because the risk of losing is less, right? Now, anything with a probability of 1 is bound to happen. It is very certain. You can't stop it from happening, right? So in terms of putting these 0 and 1 into context, we say that the probability that we are going to die is certain, right? So we would say that the probability of a person going to die is 1 because it must happen. We say that the probability of the cow jumping over the moon would be 0 because it can't happen. Not going to happen, right? I don't know if anybody have that thought in their head, because when we were, well, back in the days, way back in the days, they usually have this nursery rhyme, says, "Hey, the little cat and the fiddle cow jump over the moon." I don't know how many person, I guess they might stop using those nursery rhyme now because it is ridiculous. How can cow jump over moon? And then the little dog laugh and the dish run away with the spoon. So those are what they were teaching back in the days. But anyways, I hope you understand clearly what we mean by when something has a probability of 0, the chance of it happening, it is not likely to happen. It won't ever happen. And the probability of 1 means that it is certain to happen. And between 1 and 0, you can measure how likely or how possible your favored outcome will happen, right? Now we also look at the probability of what we are in favor of with the probability of what we are not in favor of. And when you think about it, they're really complementing each other. If we go back to this diagram here, and we think about the probability of getting odd number would be everything in the circle. The probability of not getting odd number would be everything outside the circle of A. But what you notice is that when you add what is in the circle and what is outside the circle, you would get the total of what is in the entire rectangle, which is 9. So based on that concept, we say that the probability of what you are in favor of plus the probability of what you are not in favor of will be equal to 1. Because if you go back to the here now, the probability of getting what is in the circle, you have 5 members. And so you would have 5 over the total. So that will give you 5 out of 9, right? Suppose we are to calculate the probability of not getting an A. Then we would have to look at the elements outside the circle and count those elements and put it over the total. Now, how many elements outside of A? We see that we have 4 elements outside of A. So the probability of not getting an A would be 4 out of 9. And so you can see then, if you add the probability of getting an A, which is 5 out of 9, plus the probability of not getting an A, which is 4 out of 9, if you add them, you will have 5 out of 9 plus 4 over 9. So you add the numerator because the denominators are the same. So you get 9 over 9, and that would give you 1, right? And so that is the idea behind the probability equation that we were just looking at now. All right, guys? So this is what it says. The total probability is equal. So the probability of favorable outcome plus the probability of unfavorable outcome is equal to 1. And so that is an equation that can help you in probability. So if you know the probability of one thing happening, then you can determine the probability of it not happening. Because all you would have to do is take away the probability of it happening from 1 to get the probability of it not happening. All right? So for instance, you may have, say you have a bag of 10 marbles, and out of the 10 marbles, you have 3 red marbles. And let's say you're finding the probability of red marbles, so you favor red marbles. So the probability of red marbles would be 3 out of 10. Now, by knowing the probability of red marbles, you can use that to determine the probability of not red marbles. How could we calculate the probability of not red marbles? Can somebody give me an idea?
Take away, sir.
So we'll take away what?
Take away the other color marble from the amount, and then we know that what is left would have been red marble.
So remember now, we know that the total of these two probabilities should give you 1. So the probability of red plus the probability of not red should equal to 1. So all we'd have to do to find the probability of not red is subtract the probability of red from 1. So we would take away 3 out of 10 from 1. Now, 1 can be written in terms of the denominator that we have, which is 10. We can write 1 as 10 over 10. Because 10 over 10 is the same as 1. And now we subtract 3 over 10 from 10 over 10. And so we will get 7 over 10. And so that would be the probability of not getting a red marble. Is that clear? Raise your hand if you understand, guys. Okay, good. All right, guys, just give me a split second there. Guys, just give me a quick second there. I need to post something here, all right? All right, guys, sorry about that. So as I was saying, this is how we calculate the probability. If we know the probability of what we are in favor of, then we can always calculate the probability of what we are not in favor of. All right, guys? Any question? All right, so we're going to clear this and move on. All right, so here we have another example here. So we can look at if the probability of cutting an ace, and anybody is familiar with what we mean by when we say we are cutting an ace in a pack of cards. When we cut an ace, what does that mean? All right. So if you split the card deck and then you pick up a card off the deck, I think that's what they refer to as cutting. So picking up a card off the deck after you split the deck, and the probability of getting an ace would be based on the number of aces that you have in the card pack. So that would be 4 out of 52. And so it would work down to be 1 out of 13. So if we know the probability of getting an ace is 1 out of 13, then what would be the probability of not getting an ace? So here, again, we would have, because we know that the probability of both of them, when you sum them, you should get 1. So therefore, the probability of not getting an ace would be 1 minus the probability of getting an ace, which is 1 minus 1 over 13. And as before, what we would do is we would convert one in a fraction in terms of a fraction with a numerator and a denominator. So to make one as a fraction, you use the same denominator as the fraction that you're subtracting from 1. So this denominator that we're subtracting from 1, the fraction here, the denominator is 13. So we would write 1 as 13 over 13. So that would be the same as 1. Then we subtract the probability of getting an ace, which is 1 over 13. And then if we take away 1 now, you subtract based on the numerator. So you subtract 1 from 13 in the numerator, you would get 12 over 13. And so this now would give you the probability of not cutting an ace. All right, is that clear, guys? Don't just sit there in silence now. If I ask
Sir,
so you can
I had stepped away for a brief minute. Could you explain that again, please?
Okay, so we were looking at the sum of the probability of an event happening with it not happening. And we say the sum of the two probability of something happening and not happening is equal to 1. So the probability of cutting an ace and getting a 13. So the probability of getting a 13 is 1 over 13. The probability of not getting a 13 when you cut an ace would be, we would now have to use the equation that I mentioned. So we know that the two probabilities, when you add them, you should get 1. So in other words, the probability of getting ace plus the probability of not getting ace would be equal to 1. So that's an equation. So if you know the probability of getting an ace is 1 over 13. So that would be equal to the probability of not getting an ace, and that would be equal to 1. So just as how you would solve an equation for x, you would bring the 13 over here and subtract it from the other side of the equation. So the probability of not getting an ace would be equal to 1 minus the probability of getting an ace, which is 1 over 30. So this should be 13 here. All right. And so all we need to do now is to calculate what is on the right-hand side of the equation. And in order to do that, we notice that 1 is a whole number. But in order to subtract 1 from 1 over 13 from 1, we can convert 1 in the form of a fraction. Now, to make 1 in a fraction, use the same denominator that the fraction that we're subtracting from 1. So use that denominator and write it over itself. So we put 13 over 13. And that should be clear to you that 13 over 13 is the same as 1. Right? Because 13 divided by 13 gives you 1. So 13 over 13 can replace the 1 because it is the same as 1. Now you go now and subtract 1 over 13 and now if you're subtracting two fractions where the denominators are the same, you're simply going to subtract the numerator. So you take away 1 from 13, you will have 12 remain. And you put back that over the denominator. And this 12 over 13 now would be the probability of not getting an ace. So therefore, the probability of not getting an ace would be equal 12 over 13. Is that clear now, guys? Is that clear to you, Mr. Adam?
Yes, sir.
All right. Raise your hand, guys. Let me see those of who is following so far.
Sir, could you just go over one more time?
All right. Who is that speaking?
Nasha.
Okay, Ms. Brown. All right. So let me clear what we have here. All right. Now, going back to the previous situation, Ms. Brown. Here, what we notice, based on this formula that we have here, they say that the total probability is related to this formula. So if you are in favor of something and you're finding the probability of what you're in favor of, so this would be what you're in favor of. So we say that suppose you're in favor of winning the lotto. Now, if you think about the probability of not winning the lotto, and if you add the two probabilities, the probability of not winning the lotto and the probability of winning the lotto, if you add those two probabilities, you will get 1. So that's a general rule. So the probability of something that you're in favor of to happen and the probability of the thing that you're in favor of not happening, the two probabilities, when you add them, you will get 1. Is that clear, Ms. Brown?
Yes, sir.
All right. So in this case, when we're looking at the probability of getting an ace from a deck of cards, so if you are to shuffle the card pack and you're to pluck a card from the top of the card pack, what would it be the probability of getting an ace? Now, the probability of getting an ace is based on how many aces you have in the card pack. And if you know what the aces are, if you look in the card pack and you count them, you'll see that you have 4 aces in the card pack. Now, the total number of cards in the card pack would be 52. So if you're calculating the probability of getting an ace, you would have 4 over 52. Now, if you cancel this down to a simpler fraction, you see that 4 can go into itself 1 time, 4 can go into 52 13 times. So after you cancel that down, you would get 1 over 13. So that's why we have the probability of getting an ace is 1 over 13. Following?
Yes, sir.
All right, so this is the question now. The question now, what is the probability of not getting an ace? So if we know the probability of getting an ace is 1 over 13, how can we find the probability of not getting an ace? Well, simple. We can just use the equation that the probability of an ace plus the probability of not getting an ace if we add these two probabilities, we must get 1. That's what the formula is saying. So all we have to do now is substitute what we know the probability for an ace is. We know that the probability for an ace is 1 over 13. So we take out this part of the formula and replace it with 1 over 13 because the probability of getting an ace is 1 over 13. Because we know that probability. So the probability of getting an ace 1 over 13 plus the probability of not getting 1 over ace, getting an ace is equal to 1. Following this so far, Ms. Brown?
Yes, sir.
All right, so just in the same way, if we are solving an equation, if this was an x here, to solve for x, we would bring over the number, right?
Yes, sir.
Right. So we are saying now we can just bring this 1 over 13 on the other side of the equation. But if you bring it across, it's going to become a minus, right? So the probability of not getting an ace would be on this side. But now on the other side, we would have 1 minus 1 over 13. Following? Ms. Brown?
Sir, what did you say?
You following?
Yes, sir.
All right, so all we have to do now is do the calculation on the right-hand side. How can we take away 1 over 13 from 1? So I'm saying to you that we can do this easily by making 1 in the same denominator as 13 over 13. Right, so instead of taking away 13 from this number 1, we replace 1 with 13 over 13. We just use the denominator that we have in the fraction we're subtracting, write it over itself, and it replaces the 1. And the reason why we are doing that is so that these two numbers will have the same denominator so that we can subtract them, right? And so now we have 13 over 13, which is the same as 1, subtract 1 over 13. Now the two of them have the same denominator, so we can just subtract the numerator. So the numerator would be 13 for the first fraction, 1 for the second one. So we take away 1 from 13 and we put back that result over 13. So 13 minus 1 over 13. That would be equal to 12 over 13. And that now is the probability of not getting an ace. You follow? So therefore, the probability of not getting an ace is just simply 12 over 30. You get that now, Miss Brown?
Yes, sir.
All right, good. All right, so let me clear this. All right, so that's something to bear in mind, guys. So here we have an example of that equation. All right, the Zoom may chip out shortly, so be prepared to log back in. All right, so a box contains 5 blue balls, 2 red balls, 4 yellow balls, and 9 black balls. A ball is drawn at random from the box. Calculate the probability that it will be A, a red ball, and B, not a red ball. All right, so you should understand the process of working this out. So the solution is already there, but I just need somebody to walk me through the solution as it is on the screen. Who would like to do that for me? Ms. Waysam? Are you there, Ms. Waysam?
Yes, sir.
You can walk us through that discussion?
No, sir, not right now.
All right, not right now. Mr. Adams,
Yes, sir.
can you walk us through this question?
I don't think I'd like to try this one.
You don't want that. All right, so
No.
the solution is there now. Now we have a box of balls. How many balls in total in the box?
There's 20 of them, sir.
How many you have?
20.
Everybody in agreement that we have 20 balls in the box? All right, so if we have 20 balls, that means 5 out of the 20 is blue, 2 out of the 20 is red, 20 is yellow, and 9 is black. Now, if we are in favor of getting a red ball, how many times do we have a red ball? How many red balls do we have in the box?
2, sir.
All right, so the probability of getting a red ball is how many red balls you have over the total. So how many red balls you have?
2 out of 20.
The probability would be 2 out of 20. Now, so if you convert that probability to over 20 into decimal, you get 0.1. Now that's the probability of getting a red ball. Now, what would be the probability of not getting a red bar?
18 out of 20, sir.
Right, because we are now just going to subtract the probability of getting a red ball from 1. And once we subtract it from 1, that's what we will get the probability of. So probability of red ball is 2 out of 20. That's the probability of red ball. And we want to find the probability of not red ball. So we know that the probability of getting a red ball plus the probability of not red ball is equal to 1. So what we're going to do, bring this over and subtract it from 1. So probably the probability of not red ball would be equal to 1 minus 2 over 20. And now we can convert 1 as 20 over 20. And then we subtract 2 over 20. And that gives us 18 over 20. Is that clear? Is that clear, guys?
Yeah,
Yes,
it's
sir.
actually simpler than
Right. Now, I guess what scared people is because they say decimal. Decimal is the same, guys. You don't have to worry about it. You have to just get comfortable with it. All right. So moving on now, we talk about probability of frequency distribution. Now, we would have met frequency distribution when we were doing stats. Now, but we know that the frequency, when you add up the frequency, that tells you the total of how many members you have within that survey. And then now, it's based on what we are trying to find in terms of probability. So here, for this example, a survey was carried out by some students who recorded the first digits of the registration number of some cars which passed their school. The results were obtained as follows. All right, so the first digit of the registration plate or the license plate is recorded in the first row. And the frequency is in the second row. All right, now they want to determine the probability that the first digit would be a 5. How can we calculate the probability of the first digit being a 5?